So let us discuss a question on fluid mechanics. This is from statics. So basically a tank we have with a quarter circle at the bottom as shown, and we need to find out quarter circle gate actually. So there might be some way of mechanism of opening this gate, but that's okay. The question is that the vertical component of the force exerted on this. So basically you have something like this. So on this, what is asked is this is Fy. So there will be pressure acting and this pressure is varying. Okay, it's not same because there's a difference of the height from here to here. So all this pressure when you resolve vertically, okay, that will give, so all this pressure will have, when you integrate that over this quarter circle area, it will have a force which will have components both in the x-axis as well as y-axis. So what we are interested is in this vertical force. Okay, fair enough. So let's consider, so whenever all this vertical force is asked, the best thing is to consider to just extend these limits of this till the end and consider this entire water body that's riding, that's above this. So consider the entire water column which is above, vertically above this quarter circle. So basically I have something like this. Okay, so I consider this entire water. So from here the pressure, you have a pressure force like this. I mean you have a varying pressure which will basically provide a horizontal force. There is no vertical force, remember. Okay, and from this you have so the vertical force, and on this side also you don't have any vertical force, right? Okay, so the vertical force that is acting on the column is basically equal, remember that it's entirely vertical. So on the horizontal side you have the, on the sides you have only the horizontal force. So this Fy will be the weight of the water column above the gate. Okay, so that is basically rho density into mass into g, mass of water, that is equal to density into, sorry, mass of the water into g, and mass is equal to density into volume into g, volume of the fluid into g. Now this volume of the fluid is something which is we need to calculate. Now volume of the fluid I will write as the total rectangle volume, which is will be a cuboid. So total volume will be nothing but the area of the fluid into this, in this paper, into the depth is 1 unit. That's what we are asked. So the area which is shown here, this area into the depth perpendicular to the paper, that is 1. So this AF can be written as the rectangular area minus the quarter circle area, right? And rectangular area is something which is this total into this width. So that is given in this problem as 5 into uh, so this is 4, till here it is 4 and this is 1 meter radius, so total will be 5 into 1. So 5 into 1 is the area of the rectangle minus the quarter circle. It is pi r square is the area of pi r is 1, so pi r square is the area of the circle, but it's a quarter circle, so pi r square by 4. So this is the total area. So 5 minus pi by 4 is something which is I am writing. So this is the area. So rho into AF into 1 into G, and AF we have already got. So rho is 10 power 3 water density, and AF is 5 minus pi by 4 and into G, which is 9.81. So this is a direct problem, and we get, once when we calculate, we get 41.345, we get 41.345, okay, newtons, but then again you convert, so it is 41.345 kilonewtons. Okay, 41.345. So this is a direct problem. Only thing is you have to see what is asked and how it can be calculated. Now always the vertical forces should be always calculated with the weight of the water column above, provided your free body diagram shows that. Remember that the free body diagram here on the sides you don't have any other forces, right? So 41.345 acting kilonewton. Thank you.